Hello, welcome to the second episode of the GSC tutorial. If you are new in programming or GSC, I would suggest you to stop the video and go watch the first part. I have already covered the most basic things, so now we are getting into more advanced stuff. If you are only interested in one of these things, feel free to go into the timestamp. Like in the first video, you will have on the description the link to the GitHub repository, and you will have the Black Ops 1 GSC dump, the basic script for Plutonium, and the tutorial script I have made for this tutorial. The location for the script is basically the same. Instead of T4, which is World War, we are going to T5, which is Black Ops 1. And then inside we go to the scripts, and there you go. And now let's get into the tutorial. First of all, the scopes of the variables. The scope of the variable is basically from where you can change the variable. The local ones are the normal variables that are within the functions, and they only exist there. Global variables can be changed from any script and any function. Its value is reset whenever you do a fast restart or map restart. And it's easy to identify because it has the keyword level and it's within its struct. Developer variables are best known as devars. In its name, it cannot have a blank space. If it hasn't been set yet, then it has a default value instead of having undefined. The best thing about the devars is that their values are not reset whenever you do a map restart or fast restart. To change them, you have to use the function setDevar. And if you want to retrieve the value, then you have to use getDevar for a string, getDevarInt for an integer, and getDevarFloat for a float. And these ones are its default values. Now let's go with examples. As you can see here, we have the local var with the value 2. We are going to print it. Then we are going to call this function, which takes the value as the argument, and then it's set to 7. After that, we are going to print the value. And you will see that since it's a local value, it cannot be changed out of the function. So we are going to change it inside the function, and then on the final print, it's going to be different. As you can see, on the second print is not changed, because changing a local variable from another function does nothing. They are locals. My script has run on the front-end map because I have placed it just inside the scripts. I am going to place it inside Zombie Theater, which is the map of Kinoder Totem, so it only runs if I open that map. Now we are repeating the same thing, but with a global variable. As you can see now, our variable is within the struct of level, and the function that changed the global variable doesn't need to have it pass as an argument, since I can access the level entity from anywhere. You will see now how the second print shows the value 7 instead of 2. And those are the prints, they are working as intended. Now with the devars, I'm going to create one called speed, and I'm going to convert it into an integer. We can also use getDevarInt, so we can skip the conversion, but I will use this one just for the sake of the example. Oh, and same thing with the float. So now I'm checking the current speed of the game, and if it's just created with 0 or it's 1, then I'm going to make the game go 2 times the speed. If it's already 2 times the speed, then it's going to go back to 1. I'm saving the value that I just changed into the devar, and then I'm applying the set time scale. As you can see, now the game goes twice the speed, and if I do a fast restart, it's going to change back to 1. Now it's normal game, and remember that it's a devar, so it saves between games, and if I do another fast restart, it's again twice the speed. Now we are going to make a little exercise to learn how to discover who is the entity that is calling the function. Until now, whenever a print is going on the screen, like who's the caller, we're just assuming that it just works. Now we are going to see why it's working. On the line 184 is printing the message that we just saw. However, there is not a line that says self equals something, so we don't know who's printing this. If we highlight the function, we can see that it's being used right on top of it, and it's being called by a player entity. And now player is being assigned by the self of this function, but again, we don't know who called this function. Going up, we can see on player spawn that this function is the one that is calling who is calling this function. And at the same time, on player spawn is being called by a player entity that is created on player connect. As you can see, there is an infinite loop here, and it's waiting infinitely for every player to connect. And whenever a player is connected, it passes that entity into the function. This means our prints work because whenever we are connecting to the game, we are passing the player entity into the function. Finally, on player connect is being called on init. Main and init are the names for the functions that are entry points. That means that as soon as the game is loading the map, these two functions are run. The quick summary is that whenever the game loads, it starts with the init entry point, we thread this function, then we make an infinite loop, and whenever a player connects, we use that entity that just connected, that player, to thread a function. The parameters of a function are the data that we give through the parentheses. As you can see on the function declaration, we don't know what are the weapons or the values that are holding. On this example, I'm waiting for the player to get the 1911, then we take the weapon to avoid the Samantha's love, and then we give both weapons. The only way to know which weapons are we giving to ourselves is to see the function call, and we can see that we are getting the ray gun and the thunder gun. And as you can see, we get the ray gun and the thunder gun. Okay, we have seen that functions can get data from the parameters, but they can also give some data back. To do so, they have to use the return statement. So this simple function starts with the total health at 0, gets the current zombies of the round, adds all of their health into the total amount, and then returns it. So it's going to be calculated in a different function from where it's being printed. So I'm going to wait 20 seconds to give zombies some time to spawn, and I'm going to print the countdown. And it's going to show the first round total health amount, and currently the zombies have 750 health. Now in 30 seconds I'm going to check the number for the round 2, and it should be higher because they have higher health. And it's 1000 now, so it works. We have seen how to create our own functions and how to manage the data, but what if we want to use a function that is already created in the game? In this example, I'm going to print whenever the power has been activated in the game. I'm going to give myself some points so I don't need to get zombies to open the doors, and I'm going to give myself double the speed to go faster. So the game has already a function that waits for certain events to happen, so I'm going to use that. So to call it, I'm setting the color, which is the level, then the folder it's contained, which is common scripts, slash, the name of the file, which is utility, then colon, and the name of the function. Then the parameter is going to be power on, because I want to know when is the power activated. And now a print is going to happen when I activate the power. And it works. So there is an easy way to do this, and it's instead of telling the game every single time where are we pulling this function from, we can go to the top and tell the game that we are going to include some files, in this case common scripts utility. Notice how I don't need to tell the game again where I'm getting this function from. And it works as well. This is the little summary on how to call functions from another scripts. Feel free to pause if you want to. Now we are going to learn when to thread a function. This is very important for your control flow. In this example, I have made a very basic menu. So whenever I press the use button, I'm going to activate the God mode. And whenever I press the jump button, I'm going to activate the infinite ammo. So now as you can see, I'm going to press the use button and I activate the God mode. And if I press the jump button, I'm going to get the infinite ammo. There you go. So as you can see, the infinite ammo works. And the God mode as well. Now if I jump again, I disable it. It works, I no longer have it. Now if I press the use button again, I disable it. So it works. Now we're getting back into the functions, and I'm going not to thread the God mode one. Now as you can see on this God mode function, there is an infinite loop here because we're setting God mode to true and we are stuck here basically. And since it's not threaded, it means that the other function is waiting for this one to end, but it's going to be infinite. So now if I press the use button, God mode is enabled, but if I press it again, it's not doing anything. And if I jump, I don't get the infinite ammo. This is because the function is waiting for the God mode to end, but it's never ending because it's stuck on an infinite loop. This is why threading is so important to know when to use. Almost every single time that you have an infinite loop, you will want to thread. Now we know everything about functions, but there is actually a difference that kinda matters. So some of them requires always a color. For example, for the iPrint bold text, in order to show the text, it needs a color, which is the player. So the functions that need a color are methods, and the ones like setTimescale don't need any color, so they are functions. Now we are going to learn some methods so we can make our functions as efficient as possible. Waittill is self-explanatory. It basically puts the function in a wait until the text or the event that we have passed has occurred. For example, we have this line on player connect, so it's stuck on this line until a player has connected. We can manually set those events that we are waiting for in Waittill with notify. So basically we need the color to be the same and the text or event to be the same one. They may contain some arguments. Endon is also self-explanatory. It basically kills the function or ends it as soon as the text or event has been notified. This is very useful because, for example, on our menu, when the game has ended, we no longer want this function to run. Or even if a player has disconnected, we don't need to check if the player is pressing any button because he just disconnected from the game. In this case, we can make this function more efficient by changing the while loop for our empty for loop. By having an empty for loop, we have no condition, so it's just more efficient. By sending the notify before the Endon condition, it means that we are going to kill this function if it has been already called, but not the new instance. Now, since I'm using the same function to terminate itself whenever it's called again, I can move the things to set the true and false into the same function. This way I only need to add one single line to make everything work for the God mode, instead of all these lines. In the inefficient infinite ammo function, we can get rid of the level.gameEnded by just using an Endon. Also, whenever it's repeating the loop, it's also checking the infinite ammo condition, which we can just change to the Endon. Also, we are giving ourselves max ammo even if we haven't shot, so it doesn't make much sense. And also added the notify and endons for the infinite ammo, so now we can use a empty for loop, which is more efficient. And now instead of replening the ammo each 0.05 seconds, we are using a Waittill for weapon fire, and therefore we are only replenishing the ammo whenever we have shot. And also we can get rid of the self get current weapon method, because the weapon fire notify has also the weapon name as a parameter. So as you can see, by dominating the Endon, notifies and Waittills, you can make functions way more efficient. It's very important to learn those. Now that the hard part of the video is done, let's finish with something easy. If you have paid attention to this video, you will notice from the other one that some of the prints had colors in it. The way to get some color on the text is to add this circumflex and then a number right after it. So here is the color code. I made this function to print all the colors, and I have left the number 10. It's included with the equal, so you will see what happens with the number 10. Those are the colors being printed.
You need to find the right.
And as you can see, it treats the number 10 as a 1 and then a 0, so it takes the 1 for the color and the 0 as part of the text. So that's it. Now if you head into the World at War or Black Ops 1 GSC dumps, you should be able to understand everything and recreate pretty much every single function. Remember that on this GitHub repository you have both the World at War tutorial and the Black Ops 1 tutorial examples. Also, the Pluto based script are the same, the syntax doesn't really change until Black Ops 3. The best way to learn, in my opinion, is just by take things that already exist from the stock scripts or even from my examples and then change them little by little, so you can see what are you doing with those changes. Or even make little projects by your own, just set little goals and go step by step, that's the best way. I hope you have learned something from these videos, and if you want me to focus on something specifically, you can tell me in the comments. Good luck and have fun modding. Bye!